This conference will now be recorded.
Hi, Vikas. Hi, Pushpa. Good morning. Good evening.
Good
Can you hear
morning.
me?
Good morning. Belated Happy Ugadi.
Yeah, same to you guys. So, is the celebration going on there?
No, it
It's
was
like,
us.
okay. So, people are celebrating there. Still, things
I
are
mean,
under control, or?
indoors, I would say. Not going to any
Okay,
temple.
you're from, okay. Yeah, you're not in, okay, okay. How about Vikas? Hello? Vikas, can you hear us? Think is not there.
Yeah,
Hello, Vikas.
he's on unmute. I'm not sure. Sorry, he's not on mute. I mean,
It looks to be on mute. I'm not sure what's happening. Vikas, hello. Can you hear us, Vikas? Hello, Vikas.
uh, maybe his connection is bad. Actually, internet connection here is like, I'm not sure how good it is.
But it seems to be he's connected, right? I'm not
Yeah,
sure.
yeah, he
Um,
be connected.
uh,
Not sure.
I
Because
think let me.
I lost my phone. I got it activated yesterday. So I'm really like I have some issues when I'm trying to connect some other meeting. I mean like general training, some other general trainings. So voice,
Okay, okay.
yeah,
Mhm.
voice connections are bad.
So you're in US, right? Currently, is it?
Yes, yes.
Okay, so okay, that's where so we couldn't connect like a couple of days, right? So um,
Yeah,
so
I was not able to connect because I lost my phone. I don't have contacts in any other. I mean, like I didn't save them,
oh, okay, okay,
so I could
okay,
not.
okay,
Yeah.
right, right. Don't see Vikas on the call. He's still not. Bhumesh, can you please check with Vikas once? Is there?
Yeah, sure, bro. I will check.
Yeah, thank you. So, how is the preparation going from your side? You have any questions, Pushpa, like on the previous tools that we discussed?
Actually, no, like in pipeline, I have few questions, but I have to actually go through the recorded sessions and I have to practice. Then I might come up with some questions.
Okay.
Yeah.
There is, I think, there is, if I go to, yeah, I'll share the this one GitHub URL, so you guys can go through that.
Okay.
And there is one of the project called as Jenkins assignment. Just I was working on this like couple of days. Some of the guy in US, they wanted this assignment.
Oh.
So you can go through this. I just done this completed yesterday.
Mm.
What it is doing is it's simple Java based application, and we are deploying it to Tomcat server. Okay,
Okay.
so this is how the Jenkins file would look like. We are using this. You might see this is a node, a scripted pipeline.
Okay.
Earlier we used to have pipeline, right? Declarative format. So this is we are using. We can use it in the node as well. This way, node,
Okay.
and we will have the stages like source code management. This is little. This is very useful. Like we are using some artifact IDs and POM version,
Mm-hmm.
and based on the result.
Hello.
Hi Vikas, can you hear us?
Hi.
Hello Vikas. Hello Vikas, can you hear us? Um, hello Vikas. Bhumesh, he join? I think he's on mute.
Yeah, bro, he joined, but I think he's facing internet issue.
Okay.
He's in mute, bro, actually.
So we can continue, right? That's what I wanted to check.
Yeah, okay, bro. You can continue the session.
Okay, sure. Thanks, Bhumesh. All right. So yeah, I'll I'll be sharing this assignment link, the repository. So it will be helpful for you guys to also go through this. So basically, I can connect
Okay.
quickly. And can assignment. So this is how it will look like once once you run it, right. This is a checkout SCM first stage, then you're building second stage, and it is dynamically taking this name of the project like Jenkins assignment and the version here, right?
Okay.
So it will be displayed here, and then it'll say it'll await for an approval. Okay, let's say if I run this,
Mm-hmm.
I don't think so it will work because lots of changes have been done. Let's see. And this starting to run. Anyways, let's see. So here it will ask for an approval, and it will wait for the five minutes. If within 5 minutes you're not approving, it's not going to deploy. See,
Okay.
you can see that
Yeah.
awaiting approval for deploying, and it will give the project name and the version as well. Are you ready to deploy? So if I click on proceed, then it will go to the next stage, deploying. So in the deploying stage, we are using Ansible. So you can see here, we used Ansible playbook. So this is the command we are running. Sudo Ansible playbook. This is the username on that Tomcat server, and this is the playbook that we are using.
Okay.
All right, so that's the Tomcat server. On Tomcat, we are going to deploy it. So this is how you can use it. And you can also provide the inventory file here. You can define the inventory file, but the default would be the Ansible hosts, etc Ansible host. So from there, it will pick the your host details.
Oh,
So if you're not if you're not providing anything, but if you want to provide the inventory, the host details separately, then you can go with -i and give the inventory file name there.
okay.
So that's how it will deploy to that particular environment. So environment specific, you can keep the inventory file, and then you can provide that while running the Ansible playbook. Okay, so that's
Okay.
the execute test. Basically, you are checking whether you're just trying to run the curl command and checking the response on that particular deployment. So right now it's deployed on one of the Tomcat server like this. Okay, so this is like a full-fledged deployment. Like as soon as you check in the code in the repository, it should start the build, and this whole process should run, like check out SCM and everything. So it's
Oh,
useful. Just if you want to refer to this document, I'll share the details later on. Okay.
yeah, sure. I think you shared the Git link I mean, like in our last session, but I lost it. Yeah. But maybe not this one.
Yes.
Yeah.
Yeah, you can just go to the repositories. All are public repositories. In that, you
Okay.
can select the Jenkins assignment, and you should be able to see that. Even though if you don't have the link, I'll just provide it to you guys. No problem.
Okay.
So that's the assignment, and all this Ansible related thing is present in this the deployment directory. So this is the YAML file, and this YAML file we are just calling the role, just a role we are calling the one we discussed, right? And it is applying the playbook on this Tomcat server right now.
Mhm.
And this role we are calling, and this role is what we have written the actual the YAML, like the main tasks is written in that one. So if you go to the sample, here we'll have a tasks main.yaml file. Okay, so
Okay.
basically we're not doing much here, just copying the var file to the destination Tomcat server, web apps.
Yeah.
So basically that's what the deployment is there, right? So copying
Yeah.
the latest var file to the destination Tomcat web apps.
Okay.
All right, so this might be helpful. Just keep it for a reference, and we also try to add some README file as well, so that it might be of some helpful, like you can just refer to this prerequisites and the configuration that is required. Okay.
Yes.
All right. Getting back to the topic. So Kubernetes, what it's called as. All right. So we have seen Docker containers and Docker Swarm. So Docker Swarm basically it is used to orchestrate the containers, right? So to manage the containers, to schedule it, to also, it takes end to end, like security policies and everything is taken care by Docker. So Kubernetes again, it is the same product in the sense like it is used to orchestrate your containers. So it can be either Docker containers or it can be any other container, right? So this is basically a tool which is used to manage, schedule, and deploy the containers. Okay, and this is a Google product. It was actually it came from Google, and now it's an open source tool available in the market, and it has got wide community presence where it is still being developed, and we are still seeing the updates happening on Kubernetes, right? So let's that's the background. We'll not get into more details. So we'll try to understand what Kubernetes is, what is its architecture, and how it is helpful, right? So we'll try to look at that one, and then we'll go with the lab session. We'll set up the Kubernetes cluster, and then we'll deploy the things to that. Okay. So let's look at the architecture here. Let me go to the slideshow. Okay, so this is how the Kubernetes architecture would look like. I think it's similar to what we saw in the Docker Swarm, right? We have the node machines. Node machines are again what we want to control, right? Let's say we want to deploy something, deploy a container. So we need some nodes like worker nodes, what we can call it as, right? So same, we have node 1 and node 2 here. Let me take the pen here. So we have node 1. Okay, node 1, and basically this also another node, we can call it as a node 2. So here, this is the basic Kubernetes architecture here. You can see.
Okay.
My mouse is not working properly. Anyways,
Okay.
so here we can see there is a API server. So Kubernetes has got all the APIs. So using those APIs is what we are doing the deployment, service, we are managing the pods, security, policies, configurations, and everything, right? So we are making use of the APIs basically. And these APIs behind the scenes, they are controlled by the server etcd, which is what we call as a control plane, right? This is a control plane. And we have got the control manager and the scheduler, right? The job of the scheduler is once we have written a YAML file for deployment, let's assume that the job of the scheduler would be to schedule on which of the nodes your deployment will go, your container will be deployed. Okay, so it is basically used to schedule and schedule your container on which node machines. Okay, so this is on the Kubernetes side. There is a command that we'll be using, that is kubectl. From the command line, if you want to control, if you want to like how in the Docker we have Docker command, right? From the command line we are issuing some commands, CLI mode. Okay.
Yeah.
Same way we have kubectl. Using that kubectl, we can interact with these APIs and issue some commands which will be running in the background. and it will show the deployment if you want to run and see any deployment or details of what deployments have happened, what services are running. So we can make use of the kubectl command. Now, coming to the details like how a container is deployed on Kubernetes, right? So the basic unit that is being deployed on Kubernetes is called as pods. Right? This is the pod you can see here.
Okay.
On the this is a pod, and inside the pod we'll have a container that is running. So it's not directly container. It is inside the container we have inside the so on top of the container we have the pods. So pods is what we are deploying actually. Okay, and there is something called as services as well. So services are required in case if you want to make your containers available on the network, on the internet, or on publicly available, right? So in that case, we go with the services. Just like in the Docker Swarm, we deployed services, right? So until you deploy a service, your container is useless. It is just running, but you cannot access it. In case you want to access it on the URL on the browser and make it available for the people or make it publicly available on the internet, then you need to deploy it as a service. So we'll get into all details like how a pod is deployed, how a service is deployed, how the connectivity happens, and the architecture level, what is the networking. So compared to Docker Swarm, there is a significant complexity and learning curve involved with the Kubernetes. So don't assume like, yeah, things, it is making things easier, but additionally it is adding a little bit of complexity in terms of architecture and also the learning curve. So it go with your own pace to learn these things. There are a lot of things here like pods and services, kubelet, control plane, and things like that. All right. So looking at from the end user perspective, um, he doesn't bother what's happening behind the scenes. So there is from the URL from the browser, he types in a URL, and using the load balancer, it will connect to either this node or this node. And behind the scenes, it will go and connect to the container, and it will give the result from there. Okay. So this is a basic high-level architecture of Kubernetes. So let's try to get to the next details on the cluster level, how it looks like. So on this, okay, I think you'll get more details and understanding here. Like this is a node machine. On the node, we have a containerized app, right? And we are deploying these in terms of the deployment here. And this can be a master node, and these are all the node processes that we are seeing that will be running. So this entire thing makes up the cluster, like master nodes and the node machines, like the worker nodes, will completely make the cluster, Kubernetes cluster. Okay. Any questions so far?
No.
I think it's very new. It will take some time to understand the concept. But what we're deploying is a container here. This is the container, and this is the pod that we have, the pod that is running here. And finally, we are going to deploy it. It's not clear as of now, but once we start with the lab sessions, you'll get more idea there. Okay. So this is the cluster. And again, Docker coming into picture, just we are trying to compare Docker and Kubernetes. So Docker is used to build, ship, run any application that we know. So these are all the applications that we can run, some of the examples here, and it can run both on Windows and Linux machine. So it can run anywhere in the sense on premises, physical servers, virtual machines, and on the cloud. Okay. So what are the limitations of Docker Swarm? I think some of them we can list down. Is it is very much Linux agnostic, in the sense it is preferable more on the Linux servers. So we can't use it. It is used on the Windows servers, but it cannot manage the Windows node machines. So it is very much towards the Linux servers. It can manage the Linux servers. That is what we call as a platform agnostic. There are some hassles with the storage part. Like you need to manage the volumes that are attached to the data, like with the Docker containers, whatever is the data that you want to persist. So those persisting of data is not out of the box for the Docker Swarm. So you have to take care about the storage part in the Docker Swarm. So that is one of the limitation. Also coming to the monitoring part, it's very basic monitoring that we can get from the Docker Swarm. It's a very high level, and there are not many tools which will provide you the details there. So to overcome, like these are some of them. There are many other limitations with the Docker Swarm. So in my opinion and experience, we have seen Docker Swarm used for the small projects. If you want to try out something, like if you want to try out containerization of your applications, which is on a very small level, small applications you want to manage, then Docker Swarm is the right option there. So that's what I've seen, and that's very much useful if you're having a small applications, not very big enterprise applications, or some networking, like social networking applications or e-commerce sites. So it's not easily scalable, and it cannot manage big loads and volumes of traffic. So in those scenarios, Kubernetes has an edge, and that's where everybody is, all the projects or the applications are moving towards Kubernetes. Okay, so let's look at some of the advantages. So we cannot cover all of them, but I just try to put one, like infrastructure. Like when we say infrastructure, it is we are deploying new containers every time. So we are destroying the container and we are deploying a new container. Like we call it as a immutable infrastructure. So that's the one of the advantage that we can get with Kubernetes. And the next one is a storage. So it provides remote data storage, and there are many options out of the box that comes with the Kubernetes. It is easy and fast to deploy without downtime. Like there are strategies that we were discussing a few days back, right? Canary deployments, blue-green deployments, rolling updates. So all those can be applied to the Kubernetes, and we can leverage those benefits coming out of those deployment strategies. So that can be very well applied with the Kubernetes. So that's the one of the advantage. And coming to the availability, the containers that we deploy are highly available. Like we can make use of horizontal scaling, auto scaling options are there, manual scaling options are there. So with all these options, you can achieve like 99.9% of availability of your applications. There will be no downtime. Even if you are deploying your application, you can make sure that your application is 99.9% available all the time. So these are some of the features which makes Kubernetes as one of the popular tool nowadays to manage the containers, right? So let's I think that's it on the presentation side. So what we'll do is we'll go with the lab session. We will create a cluster in Google Cloud. Okay, so let's There are other ways as well to create the cluster. So I'm going with this option with the Google Cloud. So what this does is you already have an option here to create a cluster, Kubernetes cluster. So you don't have to worry about anything. Just we can go here to the Kubernetes engine and go to the clusters. So it will create the clusters for us. So here, so we can just click on create cluster. You can leave the cluster name as it is, so not much change there. Zone you can select if you want, or you can just leave this as a default. Next, we have the default pool. Number of nodes you can select how many nodes you want. So the default pool, I want to go with let's say 2 nodes. Okay. So if you want to enable auto scaling, you can select and enable auto scaling. Then what type of nodes you want to select, the memory type and CPU, you can select from here. Customized, shared, and a lot of details are available. So based on what you select, it will be you need to be it is charged from your account. So we'll go with the basic one. This is the basic one. 1 CPU and 3.7 MB, 75 GB of RAM. Hard disk we don't require 100 GB. We'll just go with 10 GB. Should be fine. Security and metadata. Allow default access, allow access to cloud calls. Let's keep the default one. We don't need more details here. Metadata is not required. That's it, I think. So once we select that, you just go and click on the, okay, let's see what is there in the cluster. So these are required like in case you want to enable some maintenance window, if you want to enable some vertical pod scaling, right, node provisioning. So when we say vertical pod scaling, that means we are adding more nodes to the cluster. There are two types of scaling. One is horizontal scaling and one is the vertical scaling. In horizontal scaling, what happens is we are scaling up the containers. Let's say there are 2 containers. When we say we want to horizontally scale the application, then we will from 2 we will update it to let's say 5 or 10. Means we are increasing the containers. So that is what we call as horizontally we are scaling up. When we say vertical pod scaling, you are adding more infrastructure, more machines. Let's say there are only 2 nodes, 2 worker nodes. So you might need, based on the load and the traffic, based on the metrics that you have seen, that okay, you might require more machines. Then you can add to your cluster. Let's say 2 or 3 virtual machines you can add, and that can take more load. You can again then go on increasing your containers on that machines. So that is vertical pod scaling. So this is again an important question. Like they might ask like what is horizontal scaling and what is vertical scaling in terms of Kubernetes. So again, that's why I'm just emphasizing on that one. So just make sure that you get more details on what this scaling is all about. Okay?
Sure. If we enable
And
this vertical pod auto scaling, say if the load is increased, will the node number change? Just I was like, you changed from 3 to 2, so will that again change to 3, 4, or something like that? Or it is just like
yeah, even I've not tried this because I'm not using Google Cloud, but
oh,
yeah, let's see what it does here. Like say enable auto scaling. So automatically what it does is saying auto scaling dynamically creates or deletes the nodes here. So
Okay.
based on your node, so you can say how many number of nodes you want here. Let's say minimum I want 2 and maximum is 3, right? So
Mm.
what it will do is based on the load on the node machines, let's say if the load is less, then it'll go with the minimum number of nodes. Let's say I can keep it as 1, and maximum if the load increases, it'll automatically create the nodes like 3.
So this node pools and down, you have another option in clusters to say vertical pods and all. So are these both similar? I mean, like, why they
Um,
options? I didn't understand.
yeah, so let's try to understand that also. Like, say, what
Mm.
this one is saying, if I vertical pod automatically analyzes and adjusts your container CPU request and memory request. Okay, so this is basically on the container level. So what this will do is, like we were discussing, when a container is running, it
Mm.
we need to define the CPU. There's one more important topic that I would like to. Kubernetes is very interesting. There are a lot of topics that will come up. So one is about this scaling, and the other one is about the CPU request and CPU request, memory request, and CPU limit and memory limit. So this is again an important topic. I'll just note it down here so that so one is the horizontal.
Yeah.
Okay, so one is the basically the scaling part, horizontal scaling, and vertical scaling. And another one is regarding the CPU request and request memory. The other one is CPU limit and request limit. So whenever we look at these examples, like how we are configuring the CPU request and request memory. So basically, we will say like there is out of one core, my container would require. So usually one core is divided into 1,000. Um, we will divide into 1,000 time slices. Let's say we have one CPU core, so we'll divide that into 1,000 slices. So out of the 1,000 slices that CPU can provide time for any application, so we will say whether my um, container would require, let's say, only 10 millicores. It is called as millicores. So out of 1,000, it might require only 10 millicores. And request again, it's defined in megabytes. Like let's say it might require 100 megabytes of memory for it to keep on running, right? And the limit is to what extent it can go. Let's say it can go up to 100 millicores, and same thing with the request memory as well. Request limit here, so it can go up to, let's say, 500 megabytes. So it will keep on monitoring this CPU request and request memory. So based on that, it will automatically adjust. So that's what it is telling here.
Okay.
So what this is telling is, so it will keep on monitoring, it will automatically analyzes and adjusts the container CPU request and memory requests. So we don't have to worry about that one. Okay, and enable node provisioning here. So all nodes are used to compute the total resources, including nodes in non-auto scaling. Limits are enforced for all auto scaling, including those created manually. Okay, I'm not sure what it is, so we can leave it as it is. But here, this one, the default pool we saw, right? So what this will do is, this again automatically, dynamically, it does this one. This on the node level, because we are talking about the nodes right here. Currently, how many nodes we want, correct?
Yeah.
So automatically it will reduce, or it will scale down the nodes, number of nodes that we might need. This is on the container level, the cluster what we're talking here, right? This is more on the container level. So how much CPU and memory it requires, it automatically adjusts that one. So one is on the node level, one is on the container level. So this clustering what we are seeing, right? This is on the container level.
Okay.
All right, so that's the automation networking. You can either select, we'll leave it as default, because see, again, we are not interested in all these settings, because what would happen is you might work on AWS, or you might work on some other IBM cloud or DigitalOcean or some other private cloud. So these only the concepts will be of importance. Again, if you go to different service provider, the options might change there. So only thing we need to remember is the concept, like what is the scaling, what we are scaling, and on the container level, what we can scale it, right? So we will just go with the defaults here, default settings. Will not change anything here. I'm also not sure what it does if I change. Security, again, we can go through each of these, but I'm not sure what it does again. RBAC role-based. This is again role-based access control. So this is another feature of Kubernetes, wherein based on the roles, you can authorize which users can access to which of the containers. So that is again a role-based access control that we can provide. Authorization, authentication, and different certificate level. Those securities are all again part of the clustering, so that we are not getting into more details there again. So there is a separate topic, security as well. Okay. So
Okay.
metadata and other features. Okay. So telemetry, you can enable the monitoring here. Logging and monitoring, if you want, you can select. This will collect all the data, and we can analyze the data later on using some dashboards. So if you want some dashboard, we can go with this Kubernetes dashboard. You can see all the services that are deployed using this dashboard. I think it is deprecated right now, so we are not using that. Okay, so let's leave this all aside, and we'll mainly see how we'll deploy on Kubernetes, and then we'll get into the more details about each one of these topics, right?
Okay.
So let's go and create it now, for now. And there is one very good document that is available, that is from Kubernetes. So this is the one I wanted to also like tell you guys, like this is from Kubernetes itself. They have this documentation and the tutorials over here. I think you can refer to this. Here you'll also have some lab sessions also if you want to try out. Like they are given all the details what this Kubernetes is all about, and there's more details over here. What's a cluster looks like, how we want to deploy, we want to explore an application. So it's pretty much useful, and you can use the labs also here. Like let's say you want to install, you don't want to worry about all this clustering and everything. So in that case, let's say you want to create a cluster. Okay, so you can create using the Minikube. Minikube is like on a standalone. You have a laptop. Let's say you have a laptop and you want to set up the Kubernetes cluster. Then you can make use of this Minikube on your machine because you have a MacBook. If MacBook is there, then Minikube is you can use Minikube on your MacBook. So
Okay.
this will create a single node cluster. So you can make use of that one. So this is how it looks like. I've just taken this diagram from here. At the end, right, there is this tutorial is there, interactive tutorial. So this is very interesting. Like if you click on this, it will have a scenario. I think you might have heard about Katacoda something. This one.
Yeah.
There is a website with this
Yes.
Katacoda. So what you can do is you can like it'll have a scenario. So like say example is like the goal of this scenario is to deploy a local development Kubernetes cluster using Minikube, right? So you can click on the scenario and it will be around, it takes 10 minutes. So if you want to quickly understand what Kubernetes is and things like that, then I would let's suggest this one to go and try out this option. Okay, so this is one way. This document, I'll share it. I'll put it in the chat window so that we don't forget that. Let me. Okay, this is one thing, and right. So I think it is taking some time. Okay, it will take some time to create the cluster. So in the meantime, also I will update. I'll give this URL so that you guys can explore on the assignment. Okay.
Yeah.
And I have also updated some documents on the Google, no, sorry, on the AWS S3 bucket. So you can just let me see where the documents. Yeah, this one. Let me connect. Where is it connected? Okay, so let me go to S3 bucket. Okay, so this is the bucket I've created. So in this, I'm adding all the documents. So I think you guys should be having access. I've made it all public. And I'm started to upload all the documents here that like whatever we went through first right from the beginning. So let's say we want to access this one. I think you need to just go to this. Let's say how to access it. I go here. No, not this way. Okay, so this is the URL I'll provide. So I think you guys must have access to this one.
I'll try logging in and check. Can
Yes, yeah, you
can
don't.
you get the link
Yeah,
first?
don't. Yeah, I'm just pinging. You don't have to log in. Just click on that link. You should be able to see this page like this. Okay. It will list all the files of the contents here. This is one file right now, and this is another file. Two contents are there. Let's say I want to access this PDF file. Just check once you are able to access the link.
Uh, it's like I pasted you in the chat window. It's something like that.
No, this one, whatever I pinged, right? This one.
Yes, 3, right? You're talking about
Yes, S3 bucket.
DevOps
Yeah.
bucket.
Yes.
Yeah, when
That
I
one. Yeah.
open that, it is leaving me that message.
Okay. What is some error message or something?
It says 1,000 files and some code. It is, I think, is it encrypted or something? I'm not sure. Linux command. I only have like few words readable. I pasted it in the chat window.
Okay. No, this is the one you can see, right? Whatever I'm showing on the screen. Is it the same one?
No.
Okay. So you're seeing this text over there, you're saying. Is
Yeah,
that is
when
it
I
right?
open the link, it gives me this text.
Okay.
Nothing. The page is like rest. Everything is empty. Just left this script. I mean, like this text.
Okay, so let me see if I can think I had given an access. Okay, so how about this one? If I give this link, can no, just try along with that URL, just append this Linux command /PDF. Let's see if you can able to access it. Just try this like this PDF. You should be able to get the PDF.
Yes, I'm able to access it now.
Okay, which one? The Linux commands.pdf, is it?
Yeah. Yes.
Okay, but you're not able to see this basic contents, right? Okay, I need to change some settings. Go back here. Let's control. Okay, list, read. Can you try that URL again? Just that only the URL up to, yeah, this one, AWS, Amazon, AWS.com.
It's leaving me the same message.
Okay.
Yeah.
Okay, let me figure that out. I think I need to check some permissions issue,
Okay.
but you should be able to get, I'll upload all the details here. And once the access is there, then you guys can access, download these documents later on if you want to. Okay. So
Okay.
I'll put all the documents over here for your further reference if you want to go through them, right? So I can add it over here. Okay.
Okay. Okay.
All
Thank
right. Getting back to Kubernetes, I think cluster is created. So right now it is having 2 nodes, and it's already created. It doesn't have anything right now. Workloads and everything will be blank. So we can start deploying the applications, services, and things like that. So we'll go with that topic tomorrow. I think it's a lot of things discussed today. So we will look into how we can deploy an application, a container in Kubernetes tomorrow. Okay, is that okay? I think we should be fine, right? Today's session.
Yeah.
Yeah, it's fine till now.
Okay. So yeah, then please go through some of the links that we have provided, right? Kubernetes part, and some of those questions that we were discussing, right? The deployment strategies and scaling, and again those request, CPU request, memory request, and things like that. So these might be useful in your interview as well. Okay.
Sure.
All right. So
yeah.
we'll any question?
No. I said yeah. We'll go through.
Yeah, definitely. Okay. Yeah. Please go through them and let me know if you have any question. Then we'll look into them. Right. Thank
Okay.
you. Thanks for
Thank you.
joining. I don't see Vikas still online, but we'll
Thank
connect
you.
tomorrow.
Yeah.
Yeah. Bye, Vikas. And any questions from your side? How is it going? All good?
Yeah, it's good. No questions for today.
Okay. I thought you're not there on the on the session.
No.
Were you listening? Were you listening to the yeah.
I'm listening. No worries. I mean, I was not asking, but I was listening.
All right. Okay. Thank you so much. We'll connect tomorrow, and just I think take all these charts like links, so that once you disconnect, I don't think so you'll be getting those links. Just keep those links handy, and
Yeah.
we'll talk tomorrow then. All right. Thank you so
Okay.
much.
Thank you.
Thank you. Thank you. Bye bye.
Bye.
Bye.